sorting algorithm, which is bubble sort. But this time, I'm gonna code it with recursion, just like I did on selection sort on my previous video. So if you have not watched the last video, please do for selection sort. Otherwise, I'm doing this video as a follow-up on my older video on bubble sort. If you have not seen that, there's a link in the description. Basically, I've done iteration on bubble sort, but now I'm doing it recursively with recursion. So, yeah. So I am making a new array just for bubble sort. So just to make things fresh, making a new array. So this is my function for bubble sort. This will be where I'll code it. And the sorting algorithm is as shows. It is. So how it works, how bubble sort works, is that you start with an unsorted array. You loop through the entire array. Each time you check if the adjacent value is less than the one you're currently at. If it is, then you have to swap it. Let's say you compare the first one and then the second one. If the second one is less than the first, then you have to swap them. The second one is less than, you swap them. And then you then check, compare the second and the third. If the third value is less than the second, you swap them, and so forth until you compare the second to the last element. And then you repeat the process until the array is sorted. You keep looping over the array over and over until the array is sorted. So at this point, I made a second parameter in my bubble sort. It's called n. Basically, I have not decided at that point how do I implement this, because I know that I'll have to take in a second parameter that will determine whether to continue calling it itself and then or stop, because recursion is calling the function itself, and then you'll have to have a base case where your recursion stops. Here, I am testing. I am comparing whether the negative value, the following value, is less than the current value, which is like I, and then the next value is I plus 1. It's like you compare the first and the second, then the second to third, and so forth, and that's what I'm trying to do. Using the same swapping algorithm as my selection sort because it's really similar. And then the only difference is the positions I'm changing. So to recap, if you have not seen this, basically you make a temporary variable to store the old value of your current position. Then reassign that to the other value you're trying to swap, and then you override the other value equaling to the temp, which is the old value of the current one. You basically swap. And at the end, I'm going to print the array. So I am now going to test whether this part works, because if it doesn't work, then I cannot do the recursive part, which is what I would like to do at the end, but I have to make this to work. as you can see, here's our I printed the same array twice. One of them is before calling one pass of the sorting algorithm. The second one is printing after you execute one pass. So you can see there is the max value is 7777, and as you can see, it has made its way to the right, which is why it makes its way, because after you compare the following events, the following numbers, the numbers are swapped, and then the biggest value turns out to end up at the very end of the array. And now that part becomes sorted. So basically, you can tell that the righter part of the array becomes more sorted. So that's what I'm gonna try to do. At this point, I'm trying to create a stopping case where I stop the recursion. Here, I am using the end parameter to determine the stopping case, because at the end, the last pass that you want to do is where you compare only the first and second element, which is index 0 and index 1, respectively. And now, as you can see, I am struggling a little bit which end value should stop the recursion. This part of the video will be the most boring to watch, so you may want to skip till the end. Otherwise, if you want to see me watch me figure it out on my own here, then you could watch this part. So it turns out the end value must be equal to 2, because 2 would mean that your iterator I will always have to be less than the last pass. I will be less than 2 minus 1, which is 1, and that means you only run the for loop once, which which is compare the 0th index and the first index. And that will complete the sorting algorithm. I now call the algorithm recursively, calling the function itself, or method in Java. At this point, I am going to test my function, my method, if it works or not. So as you can see, I managed to sort an array using bubble sort with recursion. As you can see, the first printing of the array, this is the same array that's been printed after each pass. The first array, as you can see, is unsorted, but as you complete the next passes, you could see that the numbers are becoming more sorted in the right part of the array. And the left part is the unsorted array. It's become smaller. So as you can see, the 777 and the 3 sevens and the 4 sevens are the first one to reach the end, which is the two largest values. I chose these numbers for a reason. And somehow the array seems to be sorted even after I stop the recursion. I don't know why, but this was true for bubble sort. In my other video, the array became sorted way before I finished iterative algorithm. So this is bubble sort with recursion. I really hope you enjoyed this video. In the next video, I might do something pretty different. It will not be a coding video, but rather a video where I recite a written story made by one of my good old friends. Alright, so have a good night everyone, if it's nighttime, and peace out.